Welcome to Day 5, 3.4, Fundamental Theorem of Algebra. So we're going to talk about the conjugate pair theorem today, but one thing we have to kind of remember is what I is equivalent to. So remember, I is equal to the square root of -1. So if we square both sides, we know I squared is equal to -1. So we'll need that, or to use that concept today. So this conjugate pair theorem, this deals with complex numbers. So if a plus bi is a complex zero of a polynomial with real coefficients, then the conjugate, a minus bi, so the signs are just different, is also a complex zero of the polynomial function. So I always talk about how i's come in pairs. Okay? So if I have one answer that has an imaginary number, I know I have two imaginary solutions or complex zeros. Okay, so let's take a look at this first example. So we're going to do a lot. We're going to find zeros of polynomial functions, but now some complex zeros are fair game. Okay, so we'll go through, find all the zeros of the polynomial function, write the polynomial as a product of its leading coefficient and its linear factors. So we're going to talk about two ways to do this. So the first thing, here's our polynomial, okay? And what do? Well, first we would see if we can factor it by hand, and this has 5 terms, so we're not going to do that. So we plug it into our calculator, go ahead and find one of the zeros, okay, using your table of values. So I was able to do this. Verify it, please, that you get -2 as a 0. So -2 for x, 0 for y. I verify that I don't need any placeholders for our polynomial. And again, I can see that we don't, all right? So we go through our synthetic division, okay? And I know that I did it correctly because I got my remainder of 0. So then I've got it down to this other polynomial. So if -2 is the 0, remember x plus 2 is the factor. Since we did our division, we have another polynomial here with our coefficients. So 2x cubed minus 5x squared plus 6x minus 2. Okay, so now we needed to go to find another 0. If you went to your table, though, we just have integer values. We don't have any fractions. So you could go to your graph and calculate a 0, and you would get 1/2. Okay, and we can talk about this in class, how we would go about that if they're not integers. So we would get 1/2, and we go through our synthetic division again, and we have this 2, -4, 4 left over. But because this is a fraction, what we have to do is divide every term here by 2, by whatever that denominator is. So what we really have are the coefficients of 1, -2, 2. Okay, so now we've got ourselves that quadratic. Okay, now and again, where did I get this 2x minus 1 as a factor? Well, let's just do a little side note. If we had x equals 1/2, okay, I don't want to say x minus 1/2 is our factor, right? That's typically what we would say, but we don't want to do that. We want integer coefficients. So I notice here that we have ourselves a denominator. How do we get rid of that denominator? We would multiply both sides by 2. So now we're at 2x equals 1. And I want to make that right side equal 0. So in order to do that, I would subtract 1, and I would get 2x minus 1 equals 0. So this is the factored version of it. And that's where we got it up above to the right there. Okay? Okay, so now going back to this quadratic that we came up with, all right, let me just verify. Okay, so now we would try to factor it, right? We've got ourselves down to a quadratic. If we can't factor it, we then have to go to the quadratic formula. So in this case, that's what we'll have to do. So we go through our quadratic formula, remember, -b plus or minus square root b squared minus 4ac all over 2 times a. And when we simplify everything, look, we get 1 plus or minus I. So those are 2 more zeros, 1 plus I, 1 minus I. So how do we interpret our answer? Well, if we want to talk about it in terms of the zeros, we got negative 2, 0. We pulled that from our calculator and verified it with synthetic division. We got 1/2 as a 0. Again, we verified with synthetic division. And then from the quadratic that remained, we got the two zeros, 1 plus I, 0, and 1 minus I, comma 0. So those are the zeros, but it was asking us to write this polynomial in factored form. Okay, so factored form, if negative 2 is the 0, x plus 2 is our factor. If 1/2 is the 0, we talked about how to write that with integer coefficients, so 2x minus 1. If 1 plus I is the 0, we would say x minus that quantity 1 plus I as the factor, and we would write it like this. We would simplify as x minus 1 minus I. Okay? Then if 1 minus I is the 0, we would write it as x minus 1 minus I, and that simplifies as that factor on the end, x minus 1 plus I. This next example uses that conjugate pair theorem. Okay, so this time they're going to give us one of the zeros and we have to find the rest. So find all of the zeros of this polynomial function given 2 plus I is a 0. Well, we know i's come in pairs, so if 2 plus I is the 0, we can go ahead and make our conclusion that 2 minus I is also a 0. Okay, so now we're going to use synthetic division with complex numbers. So this can get a little tricky, and it's going to take a few side notes here. So follow along as best you can, and if you have questions, we'll address those in class. So I'm going to zoom in here. So the first thing I'm going to do is use the 0 that was provided to me. So 2 plus I goes into our box. Notice we don't need any placeholders. So let's see what this is going to look like. Okay? So we drop our 1 down, and when we multiply 2 plus I times 1, we get 2 plus I. When we add negative 4 plus 2 plus I, we get negative 2 plus I. When we multiply, this is where I need to go over and show you my side note. We've got a binomial times a binomial. So I'm going to scooch over to the side to show this. So this is our first side note. We have to multiply these two. Okay? So 2 plus I times negative 2 plus I. So 2 times negative 2 is negative 4. 2 times I is 2I. I times negative 2 is negative 2I. And I times I is I squared. Remember, we talked about I squared. So I squared becomes negative 1. The two i's cancel. We're really left with negative 4 minus 1, because this goes to a minus. So we get negative 5. So it actually works out nicely. So now we can go ahead and substitute back in for our multiplication. Now we can go and add again. And now when we multiply 2 plus I times 9, we get 18 plus 9i. So negative 36 plus that gives us negative 18 plus 9i. And now we have to multiply that again by this complex number. So I need another side note. So I'm going to go over to the side, and we're going to show that multiplication. So 2 plus I times negative 18 plus 9i, we distribute 2 times negative 18. 2 times 9i is 18i. I times negative 18i is negative 18i. And I times 9i is 9i squared. So the I squared just becomes a negative 1. So all I'm going to do is switch that sign there. So we really have negative 36 minus 9, because the 18i's cancel. And we're left with negative 45. Okay, so I'm going to plug negative 45 in. And the good news is we did this correctly because we have a 0 as our remainder. Okay, so we're not done yet, though, because we're left with this polynomial that doesn't have real coefficients. So what do? Well, I have to use that conjugate pair theorem. That's where that comes into play. Since we were given 2 plus I is a 0, I now have to use the fact that 2 minus I is my other 0. So now I'm going to use this as my other 0 and the coefficients from above within my new synthetic division setup. This one will go much quicker. We drop the 1, we multiply by 2 minus I. We get 2 minus I. The nice thing is those cancel. so it's 0. We take 2 minus I, multiply it by 0, we still get 0. 9 plus 0 is 9, and now when we multiply 9 by 2 minus I, we get 18 minus 9I, and now the good news is we get a remainder of 0. So we did this correctly. So we've whittled it down to a quadratic. So we should be able to solve this from here. And I'm going to use the square root method. Notice I can't factor it because it's a sum of two squares. So we subtract the 9, we take the square root of both sides, and we better not forget plus or minus when we take the square root of both sides. The square root of negative 9 is 3i, so we get x is equal to plus or minus 3i. So now we just have to state all of the zeros, and there we have all of our zeros listed as ordered pairs, and we are good to go. And just remind yourselves, the degree of the polynomial should match the number of zeros that you have as your final answer, and it just so happens that we had a degree 4 polynomial, and we've got 4 zeros here. If you have questions, let me know. We'll talk in class.